PHP has been on a wild ride over the past few years, with new things like namespaces, our package manager called Composer, and a whole lot more sharing and friendship between projects. And in a lot of ways, Symfony has been in the driver's seat for all of that. So congrats on making it here. You're on a path to building great applications. Let's look at some facts. Symfony is a component library. This means that you can use any part of it in any PHP project, even that ugly legacy app they make you work on. We could use Symfony's router component to give it flexible URLs. Oh, and a lot of other projects use parts of Symfony, like Drupal and Laravel. Symfony is also a framework. And because we don't have time to worry about putting a bunch of libraries together, we have the Symfony framework. This is a suggestion on how everything can work together in a consistent system. As you may have guessed by the title, we'll be using the Symfony framework here. Silex is another framework built on Symfony, and its goal is to be tiny and really easy to use. I know what you're wondering, should I use the Symfony framework or this Silex guy? Use them both, because they both use the same pieces. When you're done with this course, you'll be a certifiable Silex expert. Symfony plays nice with others. Yep, Symfony tries to be as boring as possible by following widely used standards. This makes it effortless to include and use other libraries in your projects. Want to use a component of Zen Framework? We can do that with just a little bit of configuration. Symfony is one of the top 3 most watched PHP projects on GitHub, which means you won't be lonely. There's a lot of us out there working with it. In this course, we're going to kick off your journey by building an events application. To sweeten the deal, you'll also be mastering the most important concepts used across all frameworks and web apps in general. Because Symfony steals from, builds off of the shoulders of other giants. So even if you don't want to, when you're building something in Symfony, you'll be learning best practices and probably becoming a better developer. You've been warned. In this course, we've got some big goals. Start a new project using Symfony 2. Explore the core areas like routing, controllers, requests, responses, and templating. Get comfortable with a few new tricks, like using Doctrine for dealing with the database and code generation tools. And of course, the main reason you're here, learn enough best practices and tips to impress your friends at a party. Ready? Let's go. Okay, let's get Symfony downloaded and set up. Head over to symfony.com and click Download Now. If the site looks a little different for you, that's because the internet loves to change things the minute we record a screencast. But no worries, just find the download page. All the steps will be the same. We're going to use a tool called Composer to get the project started. Composer is PHP's package manager. That's a way of saying that it downloads external libraries into our project. Oh yeah, and it's also the most important PHP innovation in years. To get it, go to, you guessed it, getcomposer.org and click Download. Depending on whether you have curl installed, copy one of the 2 install lines. Now open up your terminal and start typing wildly. Okay, that didn't work. So let's try pasting the command instead. If you have PHP 5.4 installed, run this anywhere. We'll use PHP's built-in web server. If you don't, get with it. PHP 5.3 is ancient. But anyways, make sure you have Apache set up and run the command at the server's document root. This downloads an executable PHP file called composer.far. If Composer complains with any warnings or errors, follow its recommendations to make sure your system doesn't panic when we use it. Go back to the symfony.com download page and copy the Create Project Composer command. Change the target directory to say Star Wars Events, and the last part to say @stable. This is the version number, and @stable is a neat way of making sure we get the latest and greatest. This tells Composer to download the Symfony Framework Standard Edition package into the Star Wars Events directory. That's all you need to know for now. We're going to explore Composer later. Okay, so downloading everything is going to take a few minutes. Composer is busy with 2 things at once. First, it's downloading a little example project that uses the Symfony libraries. Even while Composer is doing its thing, we can open a new terminal and move into the new directory. It contains a relatively small number of files and directories. Second, our project depends on a bunch of third-party libraries, and Composer is downloading these into the vendor directory. If you run ls vendor, you'll see that more and more things are popping up here. When that finishes, our terminal will become self-aware and start asking us configuration questions. Just hit enter through all of these. We can tweak the config later. Let's make sure that our computer is ready to run Symfony. The project has a little PHP file, web/config.php, that checks our computer and tells us if we're superheroes on system setup or if our machine is missing some libraries. We need to navigate to this script in our browser. So if you have PHP 5.4 or higher, just use the built-in PHP web server. Run this command from the root of our project. If you get an error or are using Apache, we have a note on this chapter's page about all that. We now have a web server running at localhost:8000, which uses the web directory as its doc root. We can just surf directly to the config.php file. We'll talk more about a proper web server setup later. If you see any scary major problems, you'll need to fix those, but feel free to ignore any minor problems for now. You may see two major issues: permissions problems with the cache and logs directories. Okay, since this can be really annoying, we gotta get it fixed. Basically, we need the cache and logs directories to be writable by our terminal user and our web server's user, like www-data. And if a cache file is created by one user, that file needs to be modifiable by the other user. It's an epic battle of two Unix users needing to mess with the same set of files. Of course, you're awesome and are using the PHP built-in web server. For us, our terminal user is our PHP web server user, so we don't have any issues. If you're using Apache or are having issues, check out the sidebar on this page with some tips. Okay, we're ready to get to work. Check out our first real Symfony page by hitting the app_dev.php file in your browser. Hopefully, a cute welcome page greets you. The project came with a few demo pages, and you're looking at the first one. The code for this lives in the src acme demo bundle directory. You can see the rest of the demo pages by clicking the Run the Demo button. Without writing any code, we already have a working project. Yeah, I know it's kind of lame and boring now, but it does have the normal directory structure. Let's look at the app directory. It holds configuration and a few other things that tie the whole project together. If your app were a computer, this would be the motherboard. It doesn't really do anything, but it controls everything. Most of our code will live somewhere else, in directories called bundles. These bundles are activated in the app kernel class and configured in the config.yaml file inside app/config. For example, there's a core bundle called framework bundle. It controls a lot of things, including the session timeout length. So if we needed to tweak this, we'd do it under the framework config key. Routes are the URLs of your app, and they also live in this directory in the routing.yaml file. We'll master routes in a few minutes. You can ignore everything else in the app config directory. We'll talk about them more when we cover environments. The app directory is also where the base layout file and console script live. More on those soon. After app, we have bin. You know what? Just forget you ever saw this directory. It has some executable files that Composer added, but nothing we'll need at this point. All the magic and code writing happens in the src directory. We're going to fill it with subdirectories called bundles. The idea is that each bundle has the code for a single feature or part of your app. We're about 10 seconds away from nuking it, but if you want to enjoy this demo code, it lives here inside Acme Demo Bundle. We already know about the vendor directory. This is where Composer downloads outside libraries. It's kind of fat with a ton of files in it. But no worries, you don't need to look in here, unless you want to dig around in some core files to see how things work. Actually, I love doing that. We'll tear open some core files later. The last directory is web. It's simple. This is your document root, so put your public stuff here, like CSS and JS files. There are also two PHP files here that actually execute Symfony. One loads the app in the dev environment, and the other in the prod environment. We'll go more into this environment stuff later. It's time to get serious, so let's get all of that demo code out of the way. First, take your wrecking ball to the src acme directory. Next, take out the reference to the bundle in your app kernel, so Symfony doesn't look for it when it's loading. Finally, get rid of the acme demo route import in the routing_dev.yaml file to fully disconnect the demo bundle. Refresh your browser. Yes, an error! No, I'm serious. This is good. It's telling us that the page can't be found. The demo page that was here a second ago is gone. Congratulations on your completely fresh Symfony project. Let's make our first commit. We're going to use Git, but not much is different if you use something else. And if you don't use version control, shame! If you already have a Git directory, get rid of it. Otherwise, you'll inherit the history from Symfony standard distribution, which is about 1,000 commits. Now, don't go crazy with adding files. There are some things that we don't want to commit. Fortunately, Symfony gives us a solid gitignore file to start with. The bootstrap.php.cache file is generated when you run Composer. It's super important, though you'll never need to look at it. Regardless, since it's generated automatically, we don't need to commit it. The cache and logs directories also have generated contents, so we should ignore those too. The app_config_parameters.yaml file holds all server-specific config, like your database username and password. By ignoring it, each developer can keep their own version of the file. To make life easier, we do commit an example version of the file called parameters.yaml.dist. That way, a new dev can actually create their parameters.yaml file without guessing what it needs to look like. Collaboration. We also ignore the vendor directory, because Composer downloads everything in here for us. If a new dev clones the code, they can just run php composer.var install, and bam! Their vendor directory looks just like yours. Everything is being ignored nicely, so let's go crazy and add everything to Git and commit. Find some friends. It's time to celebrate the first commit to your awesome project. Do some jumping high fives, grab a pint, and make a Chewbacca cry. Don't make Chewbacca cry. Bundles are a hipster buzzword in the Symfony world. Yeah, they're cool, I guess, but we really deserve all the credit. A bundle is just a place for us to put our hard-earned code. We might make an event bundle directory for that feature and a user bundle where we build the registration and login stuff. We'll put anything and everything into a bundle. PHP code, config, templates, CSS, and cats. Okay, not cats. We can also put other people's bundles into our project. A bundle in Symfony is similar to a plugin in other systems, but, way more hipster. Yes, we can create bundles manually, but I'd rather have someone else do it for me. Meet console, a magic executable file in the app directory. Run it to see all of the tricks it knows. Whoa, all those green words are different console commands, including a lot of things that help you work with the database and debug. I like tools as much as any programmer geek, so we'll use a lot of these over time. For now, run the generate bundle command. For the bundle namespace, type Yoda event bundle. A bundle namespace always has two parts, a vendor name and a name describing the bundle. In honor of the Jedi Master, we'll use Yoda for the first part and event bundle for our second. Unless you also work for Yoda, you'll probably use your company or project name instead. Keep these as short as possible to save typing later. Next, it wants a nickname for our bundle. We're going to be writing this a lot, and let's face it, we're busy people. So let's choose something short, like event bundle. The only rule is that it ends with bundle. Use the target default directory, but choose YAML as the configuration format. You'll just have to trust me on this part. We'll check out the annotation configuration format later. For the rest of the questions, just hit the Enter key wildly. And once the console gnomes are finished, we have a brand new bundle. This did exactly 3 things for us. First, it made an src Yoda event bundle directory with some sample bundle files. Second, it plugged our bundle into the motherboard by adding a line in the app kernel class. Third, it added a line to the routing.yaml file that imports routes from the bundle. Now, contain your excitement. We're about 30 seconds from talking about this part. But I want to share a quick secret first. If you're using PHP Storm like I am, I need you to download an awesome Symfony plugin. For everyone else, this is totally not needed. It just adds some shortcuts. Once it's installed, you need to activate it. And now we're supercharged with a ton of Symfony-specific help. You'll see this along the way. Let's face it, every page needs a URL. When you need a new page, we always start by creating a route, a chunk of config that gives the page a URL. In Symfony, all routes are configured in just one file, app-config-routing.yaml. Head back to your browser and put /hello/skywalker after app_dev.php. The code behind this impressive page was generated automatically in the new bundle. You can change the last part of the URL to anything you want, and it greets you politely. The fact that this page works means that there's a route somewhere that defines this URL pattern. I already said that all routes live in routing.yaml, so it should be there. Surprise! It's not here, but there is an event entry that was added when we generated the bundle. The resource key works like a PHP include. Point it at another routing file and Symfony will put it in. So even though Symfony only needs this one routing file, we can pull in routes from anywhere. So what's up with the @event bundle magic? The resource should just point to the path of another file, relative to this one. But if the file lives in a bundle directory, we can use the @ symbol and then the nickname we gave that bundle. Since event bundle lives at src Yoda event bundle, that's where we'll find the imported file. Aha! We found the missing route, which makes the /hello/skywalker page work. The pattern is the URL, and the name of the pattern acts like a wildcard. It means that any URL that looks like /hello/star will match this route. If we change hello to there is another, the URL to the page changes. Update the URL in your browser to see the moved page. And then be cool and change the pattern back to /hello/name. Okay, so when you generate your bundle, your route might have path instead of pattern. Scandal! Here's the story. Once upon a time, the Symfony elders renamed pattern to path, just because it's more semantically correct. And hey, it's shorter anyways. But pattern still works and will until Symfony 3.0. Sorry, that's just about as scandalous as things get around Symfony. To be with the new, I'll change my routing to use path. The defaults _controller key is the second critical piece of every route. It tells Symfony which controller to execute when the route is matched. But a controller is just a fancy word for a PHP function. So you write this controller function and Symfony executes it when the route is matched. I know the event bundle default index controller doesn't look like any function name you've ever met. In reality, it's a top secret syntax with 3 different parts: the bundle name, the controller class name, and the method name. Symfony maps this to a controller class and method. Oh, stop. Let's stare at this for a few seconds, because we're going to see it a lot. Notice that Symfony adds the word controller to the end of the class, and action to the end of the method name. You'll probably hear the method name referred to as an action. Open up the controller class and find the index action method. First, check out the name variable that's passed as an argument to the method. This is sweet because the value of this argument comes from the name wildcard in our route. So if I go to /hello/Edgar, the name variable is Edgar. When I go to /hello/Skywalker, it's Skywalker. And if we change name in the route to something else like first name, we'll see an error. Aha! So the name of the argument needs to match the name used in the route. Now the route still has the same URL, we're just giving the routing wildcard a different name internally. Let's get crazy by putting a second wildcard in the route path. When we refresh, we get a no route found error. We need to put something for the count wildcard, otherwise it won't match our route. Add /5 to the end to see the page. Now that we have a count wildcard in the route, we can of course add a count argument to the action. To prove everything's working, let's dump both arguments. One neat thing is that the order of the arguments doesn't matter. To prove it, swap the order of the arguments and refresh. We've seen this twice now. Symfony matches the routing wildcards to method arguments by matching their names. Remove the var dump code so our page works again. Routing is full of lots of cool tricks, and we'll discover them along the way. Are you wondering what other URLs your app might have? Our friend Console can help you with that with the router debug command. This shows a full list of every route in your app. Right now, that means the ones we've been playing with, plus a few other internal Symfony debugging routes. Be sure to remember this command. It's your Swiss Army knife for finding your way through a project. 3 steps. That's all that's behind rendering a page. 1. The URLs compared against the routes until one matches. 2. Symfony reads the underscore controller key and executes that function. And 3. We build the page inside the function. The controller is all about us. It's where we shine. Whether the page is HTML, JSON, or a redirect, we make that happen in this function. We might also query the database, send an email, or process a form submission here. Controller functions are dead simple. And there's just one big rule. It must return a Symfony response object. To create a new response, add its namespace to the top of the controller class. I know the namespace is horribly long, so this is where having a smart IDE like PHP Storm will make you smile. Now create the new response object and quote Admiral Akbar. And as you can see, our page has the text and nothing else. Again, controllers are simple. No matter how complex things seem, the goal is always the same. Generate your content, put it into a response, and return it. How would we return a JSON response? Let's create an array that includes the first name and count variables and turn it into a string with JSON encode. Now it's exactly the same as before. Pass that into a response object and return it. Now our browser displays a JSON string. Wait, there is one problem. By using my browser's developer tools, I can see that the app is telling my browser that the response has a text HTML content type. That's okay, we can fix it easily. Just set the content type header on the response object to application/JSON. Now when I refresh, the response has the right content type header. I know I'm repeating myself, but this is important, I promise. Every controller returns a response object, and you have full control over each part of it. All right, time to celebrate! You've just learned the core of Symfony. Seriously, by understanding the routing controller response flow, we could do anything. But as much as I love printing Admiral Akbar quotes, life isn't always this simple. Unless we're making an API, we usually build HTML pages. We could put the HTML right in the controller, but that would be a trap! Instead, Symfony offers you an optional tool that renders template files. But before that, we should take on another buzzword: services. These are even trendier than bundles. Symfony is basically a wrapper around a big bag of objects that do helpful things. These objects are called services, a techie name for an object that performs a task. Seriously, when you hear service, just think PHP object. Symfony has a ton of these services. One sends emails, another queries the database, and others translate text and tie your shoelaces. Symfony puts the services into a big bag called the mystical service container. Okay, I may have added the word mystical. It's just a PHP object. And if you have access to it, you can fetch any service and start using it. And here's the dirty secret. Everything that you think Symfony does is actually done by some service that lives in the container. You can even tweak or replace core services, like the router. That's really powerful. In any controller, this is great news because, surprise, we have access to the mystical container via this container. One of the services in the container is called templating. I'll show you how I knew that in a bit. This templating object has a render method on it. The first argument is the name of the template file to use, and the second argument holds the variables we want to pass to the template. The template name looks funny because it's another top-secret syntax with 3 parts. First, the bundle name. Second, a directory name. And third, the template's file name. This looks like the underscore controller syntax we saw in routes, but don't mix them up. One points to a controller class and method. This one points to a template file. Open up the template. Welcome to Twig, a curly little templating language that you're going to fall in love with. Right now, just get fancy by adding a strong tag. Back in the controller, the render method returns a string. So just like before, we need to put that into a new response object and return it. Refresh. There's our rendered template. Now we still don't have a fancy layout, but relax, I can only go so fast. Since rendering a template is pretty darn common, we can use some shortcuts. First, the templating service has a render response method. Instead of returning a string, it puts it into a new response object for us. Now we can remove the new response line and its use statement. Better. Now let's do less. Our controller class extends Symfony's own base controller. That's optional, but it gives us shortcuts. Open up the base class. I'm using a go-to file shortcut in my editor to search for the controller.php file. One of its shortcuts is the render method. Wait, this does exactly what we're already doing. It grabs the templating service and calls render response on it. Let's just kick back, call this method, and return the result. I'm sorry I made you go through the long route, but now you know about the container and how services are working behind the scenes. And as you use more shortcut methods in Symfony's base controller, I'd be so proud if you looked to see what each method actually does. Controllers are easy. Put some code here and return a response object. And since we have the container object, you've got access to every service in your app. Oh right, I haven't told you what services there are. For this, go back to our friend console and run the container debug command. It lists every single service available, as well as what type of object it returns. Color you dangerous. Okay, on to the curly world of Twig. Now for the absolutely hardest part of Symfony. I'm kidding. We're talking about templates. Those files where we mix HTML tags and dynamic data to build our page. We already saw that these are rendered using the templating service, usually from inside a controller. We also know that they're written in Twig, a language that feels a lot like PHP, but was made specifically to be awesome at doing templating tasks, like looping, rendering other templates, and handling layouts. If you haven't seen Twig before, trust me, you're going to love it. It's easy and a joy to work with. Twig only has 2 different tags, and we've already seen the first one, the print tag. No matter what, if you want to print something in Twig, then you'll use this double curly brace format. I call this the Say Something tag, and it's basically the same as opening up PHP and using echo. In our template, we're printing the name variable, which was passed to the template from the controller. The second tag is the Do Something tag. Its syntax is curly brace %, and we use it to do things like looping, defining variables, and if statements. It's easier to see, so let's pass the count variable into our template. Now use Twig's For tag to print the name a certain number of times. Refresh. There's a finite number of Do Something tags, and there's even a handy list on Twig's documentation page. Scroll down a little bit and check out the list on the left. So the double curly brace syntax prints things, and the curly brace % performs other language actions. If you've got this down, I'd say you've just about mastered Twig. Okay, I hate to lie to you, so there is a third tag, but it's just used to write comments. But wait, there's more! Twig has a lot of nice tricks in Sugar, like filters. We can use the upper filter to capitalize the name variable. If you're used to piping things together in a Unix terminal, this works the same way. Back on the documentation page, you'll find a big list of filters. Dang it, you can even use filters on top of filters. Twig also has functions and a cool thing called tests, which lets you write things like curly brace % if I is odd. But that's all just extra fun stuff. Despite all my Twig hype, our template is really depressing. It's got some HTML, but no layout. If only we had a base layout template that could decorate all of our page. Oh, right, there is one, and it lives in the App Resource Views directory. Actually, it's kind of plain too, but it has a basic HTML structure. To use this layout, we extend it. First, add the extends tag to the top of the index.html.twig template. Now wrap everything else in a curly brace % block body tag. Refresh and check out the source. The HTML from base.html.twig is being used, and the content from our template is rendered in the middle of it. All right, let's break this down. The extends tag says that we want to dress our template with another template. Inside base.html.twig, we have a bunch of block tags. One of them is called body and looks just like what we added to our template. Blocks define holes that a child template can fill in. The content in the body block of index.html.twig is inserted into the body block of base.html.twig. There's also a title block, which already has content in it. This block has default content, which is working since the page title is indeed welcome. Let's replace it with something a bit less boring. We know how to do this now. Just add a title block to index.html.twig. And to be even lazier, there's a shorter syntax for simple blocks like this. The default blocks in base.html.twig are just suggestions. Feel free to change their names or add some more to have an even more flexible layout. The base.html.twig file name looks weird, but it's actually the exact same syntax we're using in our controller, just in disguise. Remember that a template name always has 3 parts: the bundle name, a subdirectory, and the template file name. In this case, the bundle name and subdirectory are just missing. When a template name has the bundle part, it means the template lives in the resources views directory of that bundle. But when this part is missing, like here, it means the template lives in the app resources views directory. And since the second part is missing too, it means it lives directly there, and not in a subdirectory. In the browser, we're now staring at a killer feature of Symfony 2, the polite little bar on the bottom. This is the web debug toolbar, and you may end up loving it even more than the console. It tells us which controller was rendered, the page load time, memory footprint, security info, form details, and more. It's added automatically to any page that has a valid HTML structure, and that's why we didn't see it until we extended the layout file. Click anywhere on it to multiply the amount of information it gives you by 100. This is the profiler, which is broken down into sections. I hate to pick favorites, but the best one is the timeline. It visually tells us exactly what's going on during a request and how much time everything is taking. A lot of what you see here are background Symfony events. Symfony doesn't care about your database or the code you use to talk to it. Seriously, it's not trying to be rude, but other libraries already solved this problem. So if you want to make a PDO connection and run raw SQL queries, that's great. When we create services in Episode 3, you'll learn some life-saving strategies to organize something like this. But most people that use Symfony use a third-party library called Doctrine. It has its own website and documentation, though Symfony's Doctrine documentation is a little bit friendlier. In a nutshell, Doctrine maps rows and columns in your database to objects and properties in PHP. Imagine we have an event object with name and location properties. If we tell Doctrine to save this object, it inserts a row into a table and puts the data on name and location columns. And when we query for the event, it puts the column data back onto the properties of an event object. The big confusing mind switch is to stop thinking about tables and start thinking about PHP classes. In fact, let's create the event class we were talking about. The console can even make this for us with the Doctrine generate entity command. Like other commands, this one is self-aware and will start asking you questions. In step 1, enter event bundle event. This is another top secret shortcut name, and it means you want the event class to live inside the event bundle. Now choose annotation as the configuration format and move on to field creation. And now add the following fields: name as a string field, time as a date time field, location as a string field, and details as a text field. These types here are configuration that tell Doctrine how each property should be stored in the database. If you messed anything up, panic! Or just exit with Ctrl-C and try the command again. Nothing happens until it finishes. Say yes for the repository class and confirm generation. A repository is a cool guy we'll use later to store custom queries. All right, so what did that do? Actually, it just created 2 new classes in an entity directory in our bundle, and that's it. Check out the new event class. For Doctrine, the word entity means a normal PHP class that we will save to the database. So whenever I say entity, just scream, "That's just a normal PHP class," and your coworkers will love you. If you ignore the PHP comments, you'll see that this is a plain old PHP class. It doesn't do anything. It just stores data on its private properties. Getter and setter methods like getName and setName were generated so that we can play with an event's data. It's underwhelming, almost disappointing, and that's what makes Doctrine so interesting. Now, check out the PHP comments above the class. These comments are called annotations, and they're actually read and parsed by Doctrine. So when you hear annotations, shout, "PHP comments that are read like configuration." These tell Doctrine how it should save an event object to the database. Right now, they will save to an event table, and each property will be a column in that table. I usually like to prefix all of my table names, so let's do that by adding a name option to the table annotation. We're ready to insert data, but first I want to show you a debugging trick. Copy the web app_dev.php file to the root of the project and rename it to play.php. Open it up and remove the IP protection stuff at the top, and update the require paths since we move things around. This script boots Symfony, processes the request, and spits out the page. But I have evil plans to transform it into a debugging monster where we can write random code and execute it from the command line to see what happens. Replace the last 3 lines with kernel boot. Remember the service container from earlier? We have access to it here. To make it as flexible as possible, I'll add a few lines that help fake a real request. This is a little Jedi mind trick, so don't worry about what these do right now. Our evil creation is alive! So let's play around. How could we render a template here? Why, just grabbing the templating service and using its render method. Execute the play script from the command line. When I run it, the template is rendered and printed out. How cool is that? This is perfect for whenever we need to quickly test out some code. We can use the play script to create and save our first event object. Start by importing the event class's namespace. Let's save this wild event. To do that, we use a special object called the Entity Manager. It's basically the most important object in Doctrine and is in charge of saving objects and fetching them back out. To get the Entity Manager, first grab a service from the container called Doctrine and call getManager on it. Saving is a 2-step process: persist and then flush. 2 steps? Yeah, and for an awesome reason. The first tells Doctrine, hey, you should know about this object, but no queries are made yet. When we call flush, Doctrine actually executes the insert query. The awesome part is that if you need to save a bunch of objects at once, you can persist each of them and call flush once. Doctrine will then pack these operations into as few queries as possible. Now, when we execute our play script, it blows up. Scroll up to see the error message. Unknown database Symfony. Duh, we skipped one important step: setting up the database config. Database config is usually stored in app-config-parameters.yaml. Change the database name to Yoda_event. For my super secure computer, the database user root with no password is perfect. Now, I know you're super smart and capable, but let's be lazy again and use the console to create the database for us with the Doctrine database create command. There's also a command to drop the database. That's great until you realize that you just ran it on production, and everyone is running around with their hair on fire. Yeah, so that's a healthy reminder to not give your production database user access to drop the database. We have a database but no tables. Any ideas who might help us with this? Oh yeah, our friend Console. Run the Doctrine schema create command. This finds all your entities, reads their annotation mapping config, and creates all the tables. What? No errors? Did it work? Use the Doctrine query SQL command to run a raw query against the database. And voila, there is our event. Let's get crazy and leave the details field blank. When we run the script, another explosion. We see the error straight from MySQL, saying that the details column can't be null. So Doctrine assumes by default that all of your columns should be set to not null when creating the table. To change this, add a nullable option to the details property inside the entity. But before this does anything, the actual column in the database needs to be modified to reflect the change. Hey, console to the rescue! Run the Doctrine schema update command. This is pretty sweet. It looks at your annotations mapping config, compares it against the current state of the database, and figures out exactly what queries we need to run to update the database structure. But the command didn't do anything yet. Pass dump-sql to see the queries it wants to run, and force to actually run them. Run the play script again. Alright, no errors means that the new event is saved without a problem. Putting stuff into the database is nice, but let's learn how to get stuff out. Open up the default controller class we've been playing with. First, we need to get the all-important entity manager. That's old news for us. Like before, just get the Doctrine service from the container and call getManager on it. This works, but since we're extending the base controller, we can use its getDoctrine to get the Doctrine service. That'll save us a few keystrokes. To query for something, we always first get an entity's repository object. A repository has just one job: to help query for one type of object, like event objects. The event bundle event string is the same top-secret shortcut syntax we used when we generated the entity. It's like the entity's nickname. Use the repository's findOneBy method to get an event object by name. There are other shortcut methods too, like findAll, findBy, and find. Okay, let's pass the event object into the template as a variable. We can use Twig's render syntax to print out the name and location properties. Internally, Twig is smart enough to call getName and getLocation, since the properties are private. Refresh the page. I can see our event data, so all the magic doctrine querying must be working. Actually, check out the Web Debug toolbar. The cute box icon jumped from 0 to 1, which is the number of queries used for the page. When we click the little boxes, we can even see what those queries are and even run explain on them. Good work, young Jedi. Seriously, you know the basics of doctrine, and that's not easy. In the next 2 episodes, we'll create custom queries and use cool things like events that will let you hook into doctrine as entities are inserted, updated, or removed from the database. Oh, and don't forget, doctrine has its own documentation, though the most helpful pages are the annotations reference and doctrine mapping types. And by the way, when you see annotations in the doctrine docs, prefix them with @orm/ before putting them in Symfony. That's because of the use statement above our entity. If that's in your class and you have @orm/ at the start of all your doctrine annotations, you're killing it. We're using the built-in PHP web server, and it's awesome for development. But it only handles one request at a time, so unless you ever want one visitor, we're going to need something different. To see how this might look, we'll invent a fake domain, events.l, and set it up to point to our project. I'll use Apache, though it's more and more common to use Nginx with PHP FPM, because they're lightning fast. But all the ideas are the same, and we have a page on the official Symfony documentation with some more details. Step 1 is to modify the Apache configuration to create a new virtual host. I would love to tell you where this lives, but this is one of those files that hides in different places on each system setup. I use Apache via Mac ports, so my virtual host lives in the app directory. The configuration we need is simple. Make sure the document root points to the web directory of the project so that only files inside it are accessible via your browser. Oh, and the allow override all tells Apache that it's okay to use the htaccess file in the web directory. Now restart Apache. Yep, this command also varies across systems. Finally, we need to add a host entry to Etsy hosts. This points events.l right back at our local computer, and this file is always at the same location, except for Windows. We have a virtual host and the host entry, so let's go to events.l app_dev.php. You may get a permissions error, and if you do, just chmod 777 your cache and logs directories for now. But longer term, go back to the installation chapter for details on how to fix this. The 404 error is fine because we don't have a home page yet. Add the path to the page we've been working on after app_dev.php to see it. Let's talk more about the app_dev.php script that's always in our URL. A stock Symfony app has two different modes called environments. When you hit app_dev.php, you're running your app in the dev environment. This shows us big descriptive errors, automatically rebuilds the cache, and makes the web debug toolbar pop up. It's our debugging hero. The other environment is prod, and it kicks butt by being fast and by turning off debugging tools. To run the app in the prod environment, switch the URL from app_dev.php to app.php. What? A 404 page? Outrageous! We can't see the error, but we can tail the prod log file. No route found. Of course, Symfony compiles all of its configuration into cache files. So if we change a routing.yaml file, the cache needs to be rebuilt. The dev environment does that for us, but for speed reasons, prod doesn't. To do this, find our front console and run the cache clear command with the env = prod option. This means we're clearing the cache for the prod environment. Refresh to see your functional page in the prod environment. Awesome, but I thought we had put app.php in the URL. Where did it go? Our project came with a web.htaccess file that has two pieces of goodness in it. First, it has a rewrite rule that sends all requests through app.php, which means we don't need to have it in our URL. Perfect! The app.php was ugly anyways. Second, even if you do put app.php in the URL, it notices that you don't need this and redirects to remove it. The prod environment is only useful after you deploy, so let's get back to the dev environment so we can see errors. I feel like making someone else do some work for a while, so let's look at Symfony's code generation tools. The first thing we need our app to do is let users create, view, update, and delete events. In other words, we need a CRUD for the event entity. Want to use Doctrine to generate a CRUD? Yeah, there's a console command for that, Doctrine generate CRUD. This inquisitive command first wants to know which entity we need a CRUD for. Answer with that shortcut entity alias name that we've been seeing, event bundle event. Say yes to the write actions, YAML for the configuration format, and use the default /event route prefix. Then finish up. Ah crap, red errors. It's okay. Copy the code into the routing.yaml of our event bundle. The generation tasks tried to put this in there for us, but we already had something in this file, so it panicked. We now know this is a routing import, which loads a brand new event.yaml file. Let's run the router debug command to make sure these are being loaded. Check out the main app-config routing.yaml file. It's still only importing the one file from the event bundle. But once we're in that file, we're of course free to organize routes into even more files and import those. That's what's happening with event.yaml. It holds all the routes for the new event controller. Don't go crazy, but when you have a lot of routes, splitting them into multiple files is a good way to keep things sane. Oh, and when we import another file, the key, like event bundle_event, is completely meaningless. Make it whatever you want. But the key for an actual route is important. It becomes its internal name. We'll use it later when we generate links. Enough with routing. Head to the /event page to see this in action. I know we got Apache set up in the last chapter, but I'm going to continue using the built-in PHP web server and access the site at localhost:8000. Whoa, that's ugly. But it does work. We can add, view, update, and delete events. Easy. Let's peek at some of the code. The generated controller is like a cheat sheet for how to do common things, like form processing, deleting entities, redirecting, and showing a 404 page. For example, show action uses the ID from its route to query for an event object. If one isn't found, it sends the user to a 404 page by calling createNotFoundException and throwing the result. This helper function is just a shortcut to create a very specific type of exception object that causes a 404 page. If we do find an event, it's passed to the template and rendered. Take a few minutes to look through the other parts of the controller. I mean it. I know this all works, but the ugly is killing me. I created a custom version of each of the CRUD template files while you were looking through the controller. You can find these in the resources directory of the code download for this screencast. I already moved that directory from the code download into my project. If you think that the new template files probably extended a layout file, gold star. But I can't make it that easy. Instead of extending the base.html.twig file we're familiar with, each extends event bundle : layout.html.twig. Let's create this template. The middle piece of the three-part template syntax is missing, which tells us that this will live directly in the resources views directory of our bundle, and not in a subdirectory. Inside the new template, simply extend base.html.twig. Now we have a template hierarchy. Index.html.twig extends layout.html.twig, which extends base.html.twig. This is awesome, because all the new templates extend layout.html.twig. So if we want to override a block for all of our event pages, we can do that right here. Let's try it. Set the title block to events. Now we have a better default page title for every event page. Of course, we can still override the title block in any child template. Template inheritance, you're awesome. This 3-level inheritance is definitely not required. Keep things simple if you can. But if you have many slightly different sections on your site, it might be perfect. Look back at the routing.yaml file in our bundle. You're smart, so you probably already saw the prefix key, and guess that this prefixes all the imported route URLs with /event. This is a nice little feature. Now kill it! With this gone, the events will show up on the home page. Remove the /event from the URL in your browser to see it. Things are still too ugly. I'll copy some CSS and image files I wrote up after the last chapter. We could put these into the web directory. It is publicly accessible after all. But there's a trick I want to show you. So let's copy them to a new resources/public directory in Event Bundle. Get these files by downloading the code for this screencast and looking in the resources directory. I already downloaded and copied that directory into my project for simplicity. Now we just need to add some link tags to base.html.twig. In fact, the layout already has a style sheets block. Let's put the link tags there. Why put them in a block? I'll show you exactly why in episode 2. But basically, this will let us include extra CSS files on only one page. The page-specific CSS file will show up after whatever we have in this block. Wait a second. What should we put in the href? Only things in the web directory are web accessible, but these aren't in there. What was I thinking? Okay, so Symfony has a dead simple trick here. Actually, it's console again, with its assets install command. Get some help info about it first. As it says, the command copies the resources public directory from each bundle and moves it into a web bundles directory. This little trick makes our bundle assets public. And unless you're on Windows, run this with the symlink option. It creates a symbolic link instead of copying the directory. Now our bundles resources public directory shows up as web bundles event. There's even a few core bundles that use this trick. There's a secret. When we run php composer.var install, the assets install command is run automatically at the end. But it's not black magic. There's just a scripts key in the composer.json that tells it to do this and a few other things. The uncool part about this is that it runs the command without the symlink option. When the directories are copied instead of symlinked, testing CSS changes is a huge pain. Edit the bottom of the composer.json script to activate the symlink option. The extra key is occasionally used in random ways like this. If you ever need to do anything else here, the README of some library will tell you. Okay, now let's finish up the link tags. This is just the plain web path, except for the twig asset function. This function doesn't do much, but it will make putting our assets on a CDN really easy later. So whenever you have a path to a CSS, JavaScript, or image file, wrap it with this. This is cool, but I want to give you a sneak peek of Aesthetic, a library that integrates with Symfony and lets you combine and process CSS and JS files. When we refresh, everything still looks the same, but we've laid the foundation for being able to do things like use Sass and combining everything into one file for speed. Stay tuned, because we talk more about Aesthetic in episode 4. Let's look at a couple things that are hiding in those new template files I created. Open up index.html.twig and notice the for tag, which loops over the entities variable we're passing to the template. You're going to loop over a lot of things in your Twig days, so take a close look at the syntax. Further down, check out how we link the show page for each event. Instead of hard-coding the URL, Symfony generates the URL based on the route. Look at the event routes that were generated earlier and find one called event show. To generate a URL in Twig, we use the twig path function. Its first argument is the name of the route we're linking to, like event show. The second is an array of wildcards in the route. We pass in the actual value we want for the ID wildcard. In the browser, you can see how each link generates almost the same URL, but with the different ID portion. One more hidden trick. The event class's time field is represented internally by a PHP datetime object. We saw this in our play.php file when we created an event. To actually render that as a string, we use Twig's date filter. It transforms dates into another format, and the string we pass to it is from PHP's good old-fashioned date function formats. We got rid of the ugly, but the site looks a little empty. We'll improve things by loading fixtures, which are dummy data we put into the database. When we started the project, we downloaded the Symfony Standard Edition, our pre-started project that came with Symfony and other tools like Doctrine. Unfortunately, it didn't come with any tools for handling fixtures. But we're smart enough, let's just add a fixtures library ourselves. And by using Composer, doing this won't suck. Head over to knpbundles.com and search for fixtures. Click on Doctrine Fixtures Bundle. Yeah, the one with the high quality score. Now click again to read its documentation. Composer is a PHP dependency management library. It downloads different libraries into our project and makes sure that their versions are all compatible with each other. It works by reading the composer.json file inside your project. It downloads all of the libraries under the require key and any libraries that they may depend on. To get the Doctrine Fixtures bundle, copy the line from the documentation and paste it at the end of your require key. Each library has two parts, its name and the version you want. The name comes from a site called packages.org. You can find almost any PHP library here and the versions available. But using dev master stinks. This tells Composer to grab the latest commit to the master branch, whatever craziness that might be. Go back to the libraries page on Packagist. Anything without the dev at the end is a stable version. For me, the latest is 2.2.0. Let's use that, but add a tilde sign to the front of it. With a tilde, this really means 2.2.star. Composer explains the different version formats really well on their site. Okay, let's download this library. We'll need the composer.far file from earlier. Just move it into the project. And remember, this is just a normal file, so you can download as many of these as you want at getcomposer.org. Now run php composer.far update and pass it the name of the library. This may work for a little while as Composer thinks really hard about dependencies. Eventually, it'll download Doctrine Fixtures bundle and its dependent Doctrine Data Fixtures library into the vendor directory. While we wait, let's look at a small mystery. We know that Composer reads information from composer.json. So what's the purpose of the composer.lock file that's at the root of our project, and how did it get there? Composer actually has two different commands for downloading vendor stuff. The first is update. It says, read the composer.json file and update everything to the latest version specified in there. So if today we have Symfony 2.4.1, but 2.5.0 gets released, a Composer update would upgrade us to the newest version. That's because our Symfony version constraint of ~2.4 allows for anything greater than 2.4, but less than 3.0. Hold up, that could be a big issue. What happens if you deploy right as Symfony 2.5.0 comes out? Will your production server get that version, even though you were testing on 2.4.1? That would be lame. Because Composer is definitely not lame, each time the composer.far update command is run, it writes a composer.lock file. This records the exact versions of all of your vendors at that moment. And that's where the second command, install, comes in. It ignores the composer.json file and reads entirely from the composer.lock file, assuming one exists. So as long as you run install on your deploy, you'll get the exact versions you expected. Unless you're adding a new library or intentionally upgrading something, always use composer.far install. And when you do need to add or update something, you can be more precise by adding composer.far update and passing it the name of the library you're updating like we did. With this, Composer will only update that library instead of everything. We have the bundle! Plug it in! Open up the app kernel class and add it there. To see if it's working, try getting help information on a new Doctrine Fixtures load console task that comes from the bundle. We see the help information, so we're ready to write some fixtures. A fixture is just a PHP class that puts some stuff into the database. Create a new file in the datafixtures/orm directory of your bundle. Let's call it loadevents.php, though the name doesn't matter. To breathe life into this, copy and paste the example from the docs. Change the namespace above the class to match our project. Notice that the namespace always follows the directory structure of the file. Now we just use normal Doctrine code to create and save events. This is the play.php file all over again. Notice that we only need to call flush once. Doctrine prepares all of its work and then sends the queries as efficiently as possible all at once. Okay, let's load some fixtures. Go back to the console and try the new Doctrine Fixtures load command. When we look at the site, we've got fresh dummy data to play with. Rerun the command whenever you want to start over. It deletes everything and inserts the fixtures in a fresh state. Auto-loading. It's like plumbing. You forget it's there, but when it's gone, well, let's just say you have to go outside a bit more often. Auto-loading is the magic that lets us use classes without needing to require or include the file that holds them first. We used to have include statements everywhere, and well, it was terrible. But an autoloader has a tricky job. Given any class name, it needs to know the exact location of the file that holds that class. In many modern projects, including ours, Composer handles this. And there are two pieces to understanding how it figures out what file a class lives in. When we create an event object, Composer's autoloader knows that this class lives inside src yoda event bundle entity event.php. How? It just takes the full class name, flips the slashes, and adds .php to the end of it. As long as the namespace matches the directory and the class name matches the file name, plus .php, autoloading just works. Let's mess this up. Let's rename the entity directory to entity2. If we run play.php now, it fails big. The autoloader is looking for an entity directory. Rename the directory back to entity to fix things. Right now, it almost looks like the autoloader assumes that everything must live in the src directory. So how are vendor classes like Symfony loaded? That's the second part. When we fetch a library with Composer, it configures its autoloader to look for the new classes in the directory it just downloaded. Open up the vendor composer autoload underscore namespaces.php file. This is generated by Composer, and it has a map of namespaces to the directories where those classes can be found. So when we reference a Symfony class, it does the slash flipping trick, and then looks for the file starting in vendor Symfony src. Now you know all the secrets about the autoloader. And when you see a class not found error, it's your fault. Sorry. The most common mistake is easily a missing use statement. If it's not that, check for a typo in your class and file name. Whoa, you're almost finished with the first episode on Symfony 2. That's not easy. Symfony 2 has a learning curve, and I've been throwing a lot of tough concepts at you. As a reward, let's see a few shortcuts. Head to Google and search for Sensio Framework Extra Bundle. Click the link on Symfony.com. This bundle is all about shortcuts, and it came standard with our project. On the docs, scroll down to the @template link and click it. Copy the use statement from the code block and paste it into the event controller. Okay, let's remove the render method and just return the array of variables we were passing to the template. Finish up by adding an @template annotation above index action with the template name. When we check the page in our browser, it works perfectly. This is a bit of magic. It tells Symfony to render the template for us. Now remove the template name and refresh. This works too. Now we're talking. If we don't pass a template name, it guesses it from the controller and action name. Let's talk about the use statement we pasted in. Whenever you use an annotation, you must have a use statement for it. If you don't, you'll see a nice exception. We actually saw this already in our event entity. It was generated for us, but it has a use statement for its ORM annotation. What else can we do with annotations? How about routing? On the docs, go back and click the @route and @method link. Copy the use statement into the controller and put an @route annotation above index action. Routing right above the controller? Interesting. But like all routing, we have to import it before it works. Open up the routing.yaml file in the bundle. Copy the event.yaml import line and change the key so it's unique. To import annotation routes, just point the resource at the controller directory and add a type option. When we refresh, it still works. But things are not as they seem. Check out the Web Debug toolbar. It says that the event route is being matched. Now run the router debug console task. Uh-oh, we have two routes with identical paths. The first route is from event.yaml, and the second is from our annotations, where Symfony generates a name automatically by default. When two routes have the same path, the first route matches. So let's remove the first one in event.yaml. Now when we refresh, it works, and our route is matched. But when we try to create a new event, we get an error. In new.html.twig, we're generating a link to the homepage by using its route name event. Symfony generated a different name for the annotation route, yoda_event_event_index. Easy fix. Just add a name equals event key to the routing annotation. And just like that, life is good. For homework, read through these docs and see what other cool things you can do. I've got 2 more bonuses from Twig. In every template, you have access to a variable called app. This has a bunch of useful things on it, like the request, the security context, the user object, and the session. It's actually an object called global variables, which you can check out yourself. So when you need one of these things, remember app. Next, head to our base template. Right now, the title tag is boring. I can either replace it entirely in a child template or use the default. Let's make this better by adding a little suffix whenever the page title is overridden. This shows off the block function, which gives us the current name of a block. Refresh the events page to see it in action. But if you view the source, you'll see that we have a lot of white space around the title tag. That's probably okay, but let's fix it anyways. By adding a dash to any twig tag, all the white space on that side of the tag is removed. The end result is a title tag with no white space at all. Congrats on finishing the first episode! You're well on your way with Symfony, young Jedi, so keep going with episode 2, and of course, start practicing on a pet project. See you next time!